Welcome to Diagnostic YouTube channel. GATE 2016 Part 3. Question number 31. The correct set of IR spectral bands of mu CO, that is carbonyl stretching mode, for the given carbonyl complex is. The carbonyl complex, that is a rhodium complex, RH3, CP3 and CO3. This was given. Now all the three carbonyl compound were bridged. These are three are bridged carbonyl compounds. Now we have to find the range of these three bridged, that is mu1, this is mu1, mu2 and mu3. You have to find the IR stretching frequency. You see, generally the mu bridged carbonyl stretching frequency occurs in the range of 1850 to 1750 centimeter inverse. So this is the range. See, in this, option B was ruled out. Option D, there is only two stretching frequency was given. Option D was also ruled out. In option A and option C, you see, in option C, it is 1650. This is a very low range. Hence, this option C was also ruled out. Hence, option A is correct. You see, the range as per experimental data, mu CO is from 2150 to 1850. Mu2, second bridged, 1850 to 1750. Mu3, 1760 to 1650. So option A is correct. Question number 32. Fluorine F19 NMR spectrum of ClF3 when measured at minus 60 degree, it is a very low temperature, observed as singlet, doublet, doublet and triplet, doublet of doublet. So what will be the range? Here in fluorine F19 NMR spectrum, at room temperature, this all three fluorine will be in the same environment and it gives a doublet. But at a low temperature, you see, this fluorine exists in two different environments. This is Fa, this is Fb, Fb. Here, Fa, for Fa, it gives, there is n plus 1, there is 2 plus 1, that is triplet. For Fb, there is 1 Fa, that is 1 plus 1, that is doublet. Hence, at a low degree, minus 60 degree, ClF3 gives two signals. One is Fa and one is Fb. Fa gives triplet and Fb gives doublet. Hence, option C is correct, because there exists as two different environment of fluorine. Question number 33. Among the following platinum complex, that one which is thermally unstable is. Listen, in this platinum complex, the complex having beta hydrogen is more unstable. Hence, you find in this complex A, there was no beta hydrogen, so it is more stable. Compound B, it contains beta hydrogen. Compound B contains beta hydrogen, but due to this ring, it stabilizes the compound. Hence, it is also more stable. You see, in compound C, it contains beta hydrogen, hence it is unstable. It's a most unstable complex. And in D is a alpha and beta. There was no beta hydrogen present. This compound is also stable. Hence option C is correct. Question number 34. Shapes of XeFi plus and XeFi minus respectively are pentagonal, planar, square pyramidal. So which one is correct? You have to find it out. Listen. For xenon, generally xenon, it has 8 electrons. Now for Xe plus, that is, if you remove one electron, that is xenon, it loses one electron. This is Xe plus. And you add 5 fluorine atom, what you will get is XeF5. This 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 4 equatorial fluorine and 1 axial fluorine and 1 lone pair. 1 lone pair. So totally 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Okay. Now it is this is an square pyramidal. So this is a square pyramidal structure. This is square pyramid. This is a square pyramidal structure. Suppose you take xenon having 8 electron, xenon minus means you add one extra electron, 1, 2, 3 electron and 2. So totally there are here 7 electron, here it is a 9 electron. If you add F5, what you will get is, here you see xenon, 5 fluorine, 1, 2, 3, 4, 5 fluorine. This is a pentagonal structure, and you will have 2 lone pair. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally 9 share. So this compound has this pentagonal planar structure. Pentagonal planar having 2 lone pair. So XeFi has 2 lone pair, whereas XeFi plus has 1 lone pair. Remember this. Okay. So correct option is D. First one is a square pyramidal and second one is a pentagonal planar. Sodium salt of pseudohalogens. 3 pseudohalogens are been given X, Y and Z. These 3 pseudohalogens are colorless. Okay. First pseudohalogen X decolorizes iodine I3 solution with brisk effervescence. The solution of Y gives intense red color on reaction with Fe3 solution. Z gives a intense blue color with the solution of Fe3 and Fe2 plus ions. So identify the pseudohalogens. Remember here X is N3. This N3 reacts with iodine to give brisk effervescence. Listen. Solution N3 reacts with iodine to give brisk effervescence. Next, second pseudohalogen reacts with Fe3, that is ferric ion, to give blood red color. Blood red color, the test for ferric ion. Hence, third pseudohalogen is cyanide ion, which gives a blue color with Fe2 plus. and Persian blue color with Fe3+. So potassium ferricyanide. Hence option B is correct. On reacting 1.55 gram of diol with the excess methyl magnesium chloride Grignard reagent, 1.12 L of methane gets liberated. The molecular mass of diol. First listen, this is a diol or OH gives reacts with methyl 2 moles of methyl magnesium iodide to give methane. So listen here, 22.4 liter of methane has 16 gram. So for 1.12 liter of methane contains 16 divided by 22 into 1.12, it is 0.8 gram. Number of moles is weight by molecular weight, it is 0.8 divided by 16, it is 0.05 mole. But here you see this 1 mole of diol consumes 2 mole of methane. So it is 0.05 mole of methane is liberated, that is divided by 2, which is 0.025 moles. Hence number of moles is 0.025. Weight by molecular weight, you have to calculate the molecular weight. Weight is 1.55, it is given here. It is given here 1.55 gram. So molecular weight is 1.55 divided by 0.025, it is 62 gram. It is 62. Identify the structure of the compound. The 4 structures has been given. You have to identify the structure. Listen, from IR data is given 1690 indicates the presence of carbonyl group. So all the 4 given option contains carbonyl group. So next we have to move to next data, that is NMR data. It's 1.30, it's a triplet, shows de-shielded protons. And 2.41 you show 2H, that is a CH2 group. So CH2 group, methylene proton shows a shielded proton. And 2.32, which is a 3H, that is a CH3 group, shows shielded proton. Here, so this 1.30 is a methyl, 2.41 methylene, CH3 2.32. Hence option A is correct. Here you see, from the spectral data, option C and D was ruled out because CH2, CH3 was not present here. But in A and B, you see the CH3 is highly shielded proton. Hence, the CH3 will be at meta position. Hence, option A is correct and option B is wrong. Question number 38. A major product formed X and Y from the following reaction. Here it is a 5-membered ring compound has been given. Here it is a stock enamine reaction. So stock enamine reaction where we will get the product of enamine. This enamine reacts with the nucleophilic addition, gives the product X. And this products on epoxidation gives an epoxide to give the product Y. Hence product X is a ketone and the product Y is an epoxide. Option, you see in here the option B is correct. And option A was ruled out because this is not an epoxide, not epoxide. In option D, this bridged double bond will not occur, hence option D is also ruled out. In option C, this carbonyl group, and this is not an epoxide. It is not an epoxide. Hence option C was also ruled out. the major product S and T formed from the reaction is a 6-membered the cyclohexanone compound. You see, this is a Wittig reaction. It's a Wittig reaction which gives E-alkene. This on reaction with LiAlH4 gives an surplus epoxidation. This alcoholic compound which on treatment with diethyl tartarate and that is peroxide compound gives epoxide is a surplus epoxidation. Hence here answer A is correct. Question number 40. Among the following transformation, here product has been given, reactant and product has been given. You have to identify which reaction is a Umplaag reaction. Here you take first one, the compound reacts with H2O and on reaction with water, H2O plus gives compound which on reaction with the Umplaag reagent. This is a Umplaag reagent which gives an keto compound. This is ethyl methyl ketone. This is ethyl methyl ketone. Hence option 1 is a Umplaag reaction. Option 2 is also an on adding Umplaag reagent you will getting ethyl methyl ketone. Hence option 2 is also an Umplaag reaction. You take option 3 is a but-1-ene is a triple bonded compound and reaction gives 2-butadiene, not the product ethyl methyl ketone. In 4, on reaction with the base, it gives 2-butene. On oxidation only it gives ethyl methyl ketone, but oxidation does not occur here. Hence compound 4 gives 2-butene. Hence the correct product formed in 1 and 2 only, not 3 and 4. The product formed 1 is correct and 2 is correct, and here it is not correct, it is also not correct. Hence option D is the correct answer. So question number 41. A disaccharide does not give a positive test for tolerance reagent. Upon acidic hydrolysis, it gives equimolar mixture of 2 different monosaccharides, both of which can be oxidized by bromine water. So this is a disaccharide. This one, glucose gives tolerance reagent test, glucose and fructose. Here the disaccharide is sucrose. The sucrose does not give tolerance reagent. This sucrose on hydrolysis gives glucose plus fructose, and this glucose and fructose is oxidized by bromine water. Hence you have to identify the correct structure of sucrose here. Here option A and B was ruled out. This was not sucrose. And in option C and D, you see option D is the correct structure of sucrose. Hence option D is correct. Question number 42. The major product M and N in the following reaction. The reactant has been given. So reaction with, you see the reaction. This oxygen attracts this Li, lithium. On reaction with the PPH2, it gives the product M. This on reaction with the methyl iodide, it gives a cis compound. This gives a cis compound is N. Option D and C was ruled out. In option A and B, here option C is a trans compound. Option B is a trans compound, hence option B was ruled out. Option A is a cis compound, hence option A is correct. Question number 43. The major product P and Q from the following reaction. See this reaction. This addition gives the product P. This on addition with the pH MgBr and oxidation with the dilute H2SO4 will get the product Q. Here option C was correct, and A and the B was ruled out, and option D, the bridged double bond will not occur, hence option D was also ruled out. Here in question, now come to question number 44. A major product formed in the following reaction is, take the reactant PHBr catalyst gives pH is added here, it will be added here, and there is a 1,2 pH shift occurs to give the pH will shift here by giving an secondary carbocation, and this reaction with DMF, that is potassium acetate, it gives a double bond is formed here. Hence here, see in compound option B is correct. Compound A, the double bond will not occur here, it is ruled out. In option C, the pH will not come here, is also wrong. There was not one. In option D, there was no shift, no pH shift, no pH shift. Option D was also ruled out. Next, question number 45. The following synthetic transformation can be achieved by the following reagent. Here, what happens is the ring expansion occurs. Ring expansion and NH is added. Which option is correct? Listen. First, in Beckmann rearrangement, you know, where is a well-known rearrangement, Beckmann rearrangement. Cyclohexanone reacts with the NH2OH, and hydrolysis gives cyclohexyl oxime product, Beckmann rearrangement. And another one is a Schmidt reaction. Here also the cyclohexanone reacts with acid acide HN3, gives cyclohexyl oxime. Hence this one is a Beckmann rearrangement reagent, and this is Q. Option B is correct. A, C and D are ruled out. This is not NH3, this is HN3. The question was wrong. HN3, H plus. Hence P and Q are correct. We will meet in the next video, part 4. Thank you.